Well, hi, and thanks so much for joining me in my shop here. Today is August 30th. 30 days past September. Hey, it's the last day of August. Oh my gosh. And what I'm going to do today is I'm going to do some more sweeping using a sweep signal generator, but I'm going to focus just on the IF. So that's what's coming in store for today. Now, yesterday I wasn't in my shop. I'll show you what I was doing. Cutting a tree down in my backyard. See me up there on the tree? No, that's not me. No way I'm doing that. I had a great big tree cut down yesterday, so no shop time. I made a nice time-lapse video of it. I'll post that on my channel at some point. You can watch the tree get cut down in a matter of about 3 minutes or so, 2 minutes. So I have been watching videos about this radio. There's lots of videos about it, and a lot of show and tell, showing what they got and playing around with it and that. Not too much on the technical side of it so far. But one fellow on a video I thought was going along pretty well. It was interesting anyway. He opened up the lid like this and he started saying what each tube did, and I almost fell off my chair. This was the audio, this is the second audio amplifier tube. What? No, he had them all messed up, but I jumped out of my chair and I ran and I found this diagram here. And it turns out, yes, what I think is true is true. RF detector, oscillator, IF detector. And this is an oscillator for the CW back here. Whew, for a minute there, I thought I posted a video where I must have looked pretty dumb. But yeah, you know what? I probably did look dumb anyway. You can be right and still look dumb at the same time, I guess. So, okay, so to do the IF sweeping, I need to find an injection point. I should say one more thing. Let me make a quick diagram here. So when I did the sweeping in the last video, the results were not very impressive. Or were they? Just a pencil here. So I had, hopefully you can see this. So if we think of this as a frequency graph here, higher frequency here, lower there, I managed to get on, I think it was on my SDR, something like this happening. Only one at a time showing up. This would be the curve for the first tube, and this would be the curve for the second tube, and they're not lining up. The thing about this is, I'd be foolish to think this test was correct. I was attaching test equipment to the grid and looking at it, and that's almost certainly disturbed the grid circuit, changed the resonance point, and resulted in these curves being where they are. Probably they're both over here. I don't know. But just because it came out like this doesn't mean it's really like that. So, bearing that in mind, the other factor in that is the radio works. It works fairly well. If those two curves are juxtaposed, that's not quite the right word. If they're not aligned, then you would think the sensitivity of the set would suffer very greatly. In fact, doesn't seem to. The set seems to be ridiculously sensitive. In fact, ridiculous, I say. Okay, so I have to sort out where to inject an IF signal, and what did I say? This was a detector. And this is IF, and IF. So basically, out of this tube and into this tube. So perhaps I can just, there's an IF transformer here too. Okay, I got to study this a little bit and figure out where to feed in this signal. By the way, the sweep generator I'll be using will be this thing you can't see right now. Be this guy, as opposed to the big clunky one over here. This is good for high frequency stuff, and this is good for the up to 5 megahertz. So I should be able to set it to sweep just through the IF. This should work. It should. I promise. So I've decided, as is often the case, a good place to pick off the output is on the volume control, partially because it's easy to find the volume control wires. They're on the volume control, which is also easy to find. Here it is. On radios, generally speaking. On this one, I'm afraid it's crowded in. It's pretty hard to get your hand down there. Then there's, of course, three terminals on a potentiometer. And one of them is the one that's sliding up and down, and one is the input, and one is grounded. So I'm after the input one, not the ground one. So I'm going to try to detect the grounded one using my ohm meter and trying to make contact with it here. So let's put this on the ground spot. Here's one. I'm guessing I can somehow get a clip lead down here. That's what I'm thinking. Somehow. I have this maybe in the middle too. That might just be a... shouldn't help, but... Okay, so this is the... Oh my gosh. I think that's the upper terminal. I don't see anything happening here on the meter. Okay, we'll go for the lower terminal. I hit something. I think I hit the chassis. Holy smokes. And I have to set a camera up to watch what I'm doing here. It's one of those cases you put your hand in, and so that's what we're getting there. 600, that's not what I want. I'm on the 2 million scale, so that would be 600,000. Sounds like I'm on the middle terminal. Looks like I'm on the middle terminal. Let's try again. Upper terminal. Really hard to get at. Yeah, same number. Come on, it can't be the case. Okay, this isn't going well. I don't think I'm going to get too much certainty here doing this way. So, what should I do here? How did I get those weird readings? I'm going to try to stick a clip lead on what I believe should be the non-grounded terminal. So here's the volume control. The 3 terminals are sticking out this way. So if I turn this to 0, then I've brought the slider into contact with the ground, and I've turned it this way, so I think it's like this. Maybe the top one would be the signal. The signal one, as I move this upwards. Holy crap, this is full blast. I'm not sure. I have a hard time thinking about things like this. Boy, I don't know. Yeah, this is the easy way. The easier way is to flip this thing up on its side and hunt down the wires underneath. And that might be the easier way. I have to do this whole thing by touch. I don't think I can do it. Part of what's making it crowded in here is the audio output transformer that's in here. I have no idea what I'm doing. I have no idea where I'm going with this. Okay, this didn't work. This did not work. I got to come up with another method. From here you're tracing wires pretty much. So here's the volume control here. The input side, capacitor, and then to here, and then finally up through this resistor, and then you're looking at actual detector action. Yeah, I'm thinking ahead quite a ways here while my mouth is still operating. So I think I don't know what to do here, because trying to find these, I guess I can find a bundle of wires coming down from the volume control, and they might lead me right to here. Go through a capacitor on the way there. Yikes. More ideal location. Well, this is actually a very ideal location. Other side of the capacitor is better, but I'll just use my own capacitor. This would be the output then, rectified output here. So here's what I'm going to do. I'm going to do the easy thing. So I already have this attached here. This will be the input from the signal generator going in here, going into the grid of the mixer tube, and then that signal will come out of the mixer tube and head for the IF, which is here, here, and here. And I'm just going to tap the top of these guys with my scope, and we'll see what we see. And then I might be done, because I really got to go outside and start fiddling around with 2 tons of wood that are in the backyard there. This light has a funny wave. See the waves coming out of it? Waves coming out of it. Can't see that with your eye. Okay. Okay, let me stop for a minute. Drink a little coffee, and then we'll get it set up and do it. Do it. Do it live. Okay, before I turn the set on, I'm going to practice a bit. So here's my scope. The problem, you cannot see the scope. What I'll do is I'll turn on this camera. You'll be able to see it up close while I'm doing this, and then I'm going to I'll have the signal generator connected here, and I'm going to look for the signal. Put this ground here. This would be the first place to look, right here. This would be set to the times 10. Yep. Okay, I think we're ready there. I've disconnected the antenna, and for some reason I thought putting a dummy antenna would be good in here. This is a connector with a 50 ohm resistor stuck inside it. Maybe that's not the best thing to do, but just trying to make sure or reduce any input that might be coming in. The radio seems to be so sensitive. Audio down. And this is off. That's good. I think we're ready to start here. So let me put on my headphones. And this is what we hear right now with the radio not operating. Just a hum. I had to turn that up fairly high for you to hear that. Okay, so first step in turning it on is firing up the tube heaters. Here we go. You sure? Are you sure? Oh, we need this set to read the B plus here. Okay, here we go. Heaters first. Volume is right down. Let me turn it up a bit. Probably got. No, it sounds about the same. I was going to say probably have more hum. While they're warming up there for a minute, like I say, I have another one of these radios. It's older than this one. I know it's older because of the style of the knob here, and a couple other reasons. It's not one of these. It doesn't have 3 outputs. It's an older version. You turn the knob and nothing happens here. Nothing moves. Oh my God, I thought it's wrecked. And then I was turning the knob rather vigorously the other day, trying to yesterday in fact, and then it came right off in my hand. The knob was loose on the shaft. So that's where that one stands. I thought, oh my God, you turn this and nothing happens here, it's wrecked. No, it's just a loose knob in the end. Okay, I think we're ready to start here. So B plus time. So let me turn it down first, and here we go. What are we going to hear? I'm not sure. This is going to act as a bit of an antenna. I don't know what we're going to hear. We'll probably hear something. This is audio's on 0. Okay, now we'll take it up to, I'm going to watch this meter straight up. Things are awfully quiet. That's because I don't have the sound on. Duh. Okay, let's just repeat that. That was a mistake. Okay, I put the audio up on my sound sound control panel there. There must be a hum in the B plus of this power supply. Okay, so we're on around 150 volts. Radio's doing its usual thing. Not quite as much crashing. Let's turn this up a bit. You hear a bit of a hum come in and a bit of a hiss come in with this. So let me turn it down again. Touch that. Don't hear a thing. I thought we would hear something. Turn the sound up. Maybe just because I turned it down. Don't hear any effect whatsoever. How do we even know the radio's working? How do I know this is engaged? These guys are engaged properly. It helps I have to plug it into an antenna and listen and make sure the radio's operating before I do this. Shoot. Well, just carry on. Maybe I'll prove it's working. So we'll put the sweep generator onto here. And we should hear something then. Now let me just make sure the output is way down. Okay, it's about as low as it can go. So the sweep is set to sweep through the IF from 4 from I can't remember, from 440 to 470. That's where it's sweeping, right through the IF here. Oh yeah, okay. Audio down, audio down. Now this is the tube with the cap that's broken off of it, or it's come off. Yep. So what we should hear is a buzz. We should hear a buzz. This darn lid. Okay. I don't like holding on to this and touching my equipment at the same time. I'll just stay on the plastic knobs here. There it is. Okay, there we are. Let me do it this way. There. Okay, so I'm pretty sure we're hearing the sweep. I'll stop the sweep. Yeah, there's no question. We're hearing the sweep. Okay, good. That's good. That means I'm getting something into the radio. And we'll start looking at what's coming out. And I'm just gonna go through these grid caps here. These 3 grid caps, while you watch this other camera here, which got a funny angle to it. Okay. Not really in focus, is it? Okay, that's pretty big on your screen. Now, I'm going to touch the end of the scope there with my finger. I think we got things way too sensitive. So that's my finger. So that would be a 60 cycle. And it's waving because of the way the sweep is not from the scope itself. The sweep is coming from the sweep that's causing the line to go across is coming from the sweep generator. It's a different sweep. There's 2 sweeps. 2 sweeps coming out of the generator. Okay, volume up. First tube. Oh, I just killed the signal entirely when I touched it. That doesn't mean we can't see something here. I'll make this more and more sensitive. Now, what are we hoping to see? So we're hoping to see some kind of a response curve here. Let me give a little more juice. Ooh, 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 ooh. That was me bumping the high voltage lines there. A little more juice. More juice. More juice this way. Okay, now we're getting something. Let me turn it down, the audio. Now For all I know, I'm overloading these tubes, something terrible. But see how wide it is here and narrow there? Okay. Again, I could be throwing the resonant circuits off with doing this test. We'll go to the next tube and see what it looks like. Oh, now that looks a little better. That definitely looks a little better. It looks better on the camera than it does when I look at it with my own eyes. See, there's double lines here. You can't see them on the camera. Let me just center this a little bit better. So yeah, well, so I tried to arrange it so the center of the sweep would be 455. You can see they're close to the center here. Okay, I'm going to the last tube here. Let's not listen to the hum there while you know what that does? I hear that sound. Oh, I don't want to hear that. So I start moving fast, and that's part of the formula for having an accident. So I don't want to do that. So I'm just placing the ground back on. Here we go. This will be the last. Oops, the last tube. That was the volume control going out of control. Hey, what happened? Did I step on my wire here or something? Here we go. Last tube. Wow. Okay. Now, I'm going to tune the radio. This should not affect this. Okay, so I'm tuning the radio. Does not affect it. Okay, that's good. Turn on the crystal. Here, crystal turning on. I'm turning the control back and forth. That's the crystal off, crystal on. Now there's a selectivity control. Oh my, look at that. Okay, phasing control. What is going on? Off. So off looks like that. Looks like some kind of duck flying, the flying duck. And if I turn the phasing all the way, we get the flying duck and his feathers. Isn't that interesting? But you can take the feathers off by doing that. Okay, so selectivity again. All the way to the left, all the way to the right. In the middle, the bird gets fat. The fat bird in the middle. That's straight up now. Okay, and turning, that's with the crystal off. Crystal on, and then rotating the crystal phasing control. Yeah, wow. Is that supposed to look like something sensible? This is now the high-speed bird version here. This is the, and that's the loon. Oh boy. Let's go back one tube. Let me just flip cameras for a moment so you can see what I'm doing here. That's what I'm doing. Just holding this on the grid, and then I was turning these controls and giving us the effects we were looking at on the screen. Maybe I'm going to stop and put that right up on the screen so you can keep an eye on my other hand here. So no, it doesn't really make much. It doesn't make much difference to the operation of the radio, so it appears. That's good, because when I did this tube, it knocked it right out. Okay. Now, that was an awfully busy thing. I'm gonna go have some coffee. Next time we'll put the scope up on the screen over here somewhere, maybe over here, and then you can watch the whole thing happen. We'll try to understand what's going on. I actually don't think we're gonna. Let's take a look at the schematic here for a minute. So here's the first two RF tubes, which I'm ignoring. I'm injecting the signal into the grid of this tube. The signal is then working its way through all these tubes and arriving at this tube where I've attached the scope to the grid. Now that's kind of a weird thing. This is the first audio amplifier. The grid I've attached it to, unless I'm mistaken, let's zoom in on this picture here. Zoom way in. That's as far as we can see. Hello, how do you, wow, I can hardly see that. Slider bar. So, I'm on the grid of this. I'm on the grid cap. So right between the 4 and the 2 is a little grid cap symbol. We'll track this back. It's coming right from the output of the volume control. It's not quite where I want to be. I really want to be on the input high side of the volume control. I want to be up here. So I can be there if I turn the volume up full. Does that sound like a good idea? If I turn the volume up full, and then why would that benefit my test? It's going to give a little more of a signal for the. It's going to give you a. See, like I don't even want audio coming up here, and I'm looking at RF. Now, this could easily be nothing more than proof that all the capacitors in this radio are begging for replacement. All these things that are happening and I'm seeing that look weird could all be coming from bad components, resistors too. I've done nothing to this radio so far. I'm still just trying to sort of do enough tests that I really have an idea of what's happening in it. It's very fortunate that I can just sit here and let it operate like this without too much concern about things burning up or whatever. Well, if I turn this down to 0, we should lose the scope presentation, and if I turn it up, we should get a bigger and bigger image on the scope. That would verify that what I think is going on is what's going on here. I'm not making some kind of mistake. The next easiest connection was the grid of this tube, and this grid is just coming out of the transformer here, but we got a fairly good looking result. And when I tried it on this one, we got a really weird looking result. And in this case, the grid is coming out of this complexity here. Oh boy, oh boy. And there could be numerous troubles in here. I've read about this crystal needing to be removed from its holder and cleaned and then replaced in the holder. I've never heard of anything like that. So at some point we'll be looking at that, I suppose. Here's the switch that I've been switching. You see it shorts this right out. And what this must be a it says selectivity control, phasing control. So these are front panel mounted controls here. Okay. But then there's all of this internal stuff. Whoa. One of the things I'll need to do at some point, probably much further down the way, is figure out exactly what frequency this is oscillating at, the crystal is oscillating at. There's probably a method to use aside from what I might try. I might try just feeding in a variable frequency, which is what I'm doing right now with a sweep, in fact. It's exactly what I'm doing. And then you would examine the output from here, which I'm guessing you would pick up off the grid here. This could be a very, very high impedance. What does that say? 500, is that an M? They're using M, looks like an M, so that's really 500K. You know, I should be able to touch the top of this grid without throwing it off too much. I think. Maybe. So why don't we go back, we'll concentrate on this tube. So we're basically looking at the output from here. Kind of what we're looking at. And the output is getting there because I'm feeding a signal into the grid of this tube. Okay, let's do that. We'll fill around with the controls and watch what happens on top of here. Okay, here we go. So I've still got the sweep going into the first mixer, and we're going to go to the first IF tube grid. This is the output coming from the crystal here, right here. And what do we get? Hot diggity dog, look at that. Look at that. Well, that's exactly right. Now, I already fiddled with this momentarily to make sure it worked. I discovered this. If I turn the selectivity control, look what's going on here. That's not expected, is it? This is the selectivity control being turned with the crystal off. So you're moving around. What are you moving around? What are you moving around? A resonant point. You're moving a resonant point around. That's not selectivity. Selectivity is this should sit in one spot and it should pinch down and become taller, not move back and forth. Okay, we'll turn on the crystal here. Let me just dip the camera a bit lower. Look it on. Signal pretty much disappears. We'll move the selectivity around. Do you see it? There's what's left of it. Now it's going up and down. But it's very, very, very small. Okay, so we'll turn this up, 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 up. What's happening now? We'll turn the selectivity around. Wow, I don't know. Is this working in any way the way it's supposed to work? I don't think it is at all. It's interesting what it's doing. Basically, you're moving the. Gee, I don't know if this is really true, but you're kind of shifting the IF frequency. Is that really true? So we don't know where 456 is on the screen here you're looking at. We're guessing. I'm guessing it's where the little bibblies are on there. I don't know that for sure. We'd need to introduce another signal generator to figure out where 455 actually falls on this. This is really weird stuff here. Because when I turn on the crystal circuit, we lose almost everything until I turn this to maximum. This is a capacitor. So it's not a resistor yet. Look at that. So perhaps we're way out on the fringes of a resonant point. Like if my screen were much wide, I can make the screen much wider. I can do that. Let's do this. Now this is going to throw the calibration way off. Whatever little bit of calibration I had. So what I'm doing is I'm increasing the width of the sweep through here. Oh look, there's another bump coming up. That's. I have to stop for a minute to go any further. Let's move the selectivity around. Well, there's something over there on the left. It gets there. Oh, look at that. She's real happy, and that's right at the maximum here, where somebody aligned it once. Do you think? So we'll go back out here. Again, selectivity? I don't know. I don't know how these crystal devices actually work. I actually really don't. You know, in terms of in the radio, I know how a crystal works. So again, we'll pull it down to nothing. Now, that's with it off. Crystal phasing is off. Crystal is shorted out of the circuit. So now we're looking at just whatever this is. Okay, so now the next question is where the big bump is. Is that 455? And what happens if we go further along in the tubes? Let's go further along in the tubes. Oh baby, where did that come from? This is not good. Ooh. Yeah. Let me turn this on. Okay, tremendous weirdness is going on here, and it could be sourced from all kinds of stuff. Wow. Okay. Let me go to the next tube. Next tube, please. Oh, don't bump that, Jim. Don't bump that. That's a precarious connection. Okay, this is the this is basically the audio. Oh, made myself jump here. Well, you can see me. You can hear it bleed off the what I believe I hear bleeding off the bias on the tube. Let's try it again. Well, there's nothing there now. So if there was a bias voltage on this tube, it probably shouldn't be there. It's getting there through a leak and a capacitor, and then I bled it off. And because the capacitor leak is so high, an impedance, a very small leak, I just bleeded I bleeded the charge away, and it did not return. But it will return probably over time. Okay, never mind all that. Just kind of, yeah, leaky capacitors. Okay, so first we'll do the phasing is off and selectivity. What happened to the big bump over here? Where'd the big bump go? Let me turn it up a little bit. Yeah, because this is now restricted by the volume control. Okay, let me turn it down on the sound panel. Turn it up here. Ugh. Yeah, doesn't that look painful? Okay, selectivity moving around. Not much happening. But, well, yeah, there is something happening. Something. Goodness knows what that is. Turn on the phasing. Move this around. There's all kinds of weird stuff happening. And just in case. No. What else is on here that would have to be fiddled with? RF gain. Was I just overloading the radio? I'm pumping a pretty strong signal into it, I think, at this point. I think I've got giving it all it's got, basically. I got my signal generator right at a high level. Now, it doesn't have much output anyway, but it's still at a high level. So what does all this mean? We could be looking at a very sick radio when it comes to some of these controls, and we're just seeing the sickness on the screen, and trying to analyze it is a little bit of a exercise in frustration. Who cares? If it really is due to bad capacitors, replace the capacitors and this stuff will start making normal sense. It'll start looking the way it's expected to look. The shocking thing about this is the radio seems to work pretty well. Although these controls didn't seem to make sense to me. They seemed irrational. When I was moving around, I couldn't get a feel for anything. Except it was very loud when it was over here. And again, the test itself could be distorting or affecting the circuit in here. So again, we're not getting a really good look at it. Well, I'm going to stop at this point. I got lots of stuff to think about now, and then I've got an awful lot of wood out back of my house. I got like a ton and a half of wood to fiddle around with. I'm going to go fiddle around with that. It's a beautiful day outside today. What am I doing in here? Yeah, that's enough. That's enough. Okay, I'm going to shut down the mill. Shut down the mill. Okay, she's shut down. So thanks a lot for watching today. And tomorrow, I'm not sure what I'm going to do. I got to think about what I've kind of encountered. I think that's the way to what I've encountered here, and what the next logical step is. And if you haven't figured it out yet, I'm doing everything I can to avoid making any changes to this radio while I'm learning about it, both learning generally about these radios and learning specifically about this particular model of it. So I'm being very, very cautious. I really think this is one of the most historically valuable radios I've had. Now, there's a lot of these around, so this isn't the only example. They're all over the place. So I'm not too worried about that. On the other hand, this has got the three outputs here. This is very unusual. It's a Canadian thing, and as far as I know, there's only a few of these floating around. So, built-in output transformer. That's a very handy thing. Okay, thanks a lot for watching, and I'm on my way outside to have a great day. You too. See ya.